Hey, and welcome to Intro to Forecasting 3. Today I want to talk about building intuition. This video is going to be split into 3 parts. The first part is going to talk about different ways of thinking about probability so that you can experiment with some of them. I then want to look at actually just how to directly practice having a probabilistic intuition and how to train it. And then through the tool we're going to be using to do the practice, I want to talk a little bit more about what calibration and discrimination are. So when we start thinking about probability, there's lots of mathematical ways of describing the same thing. You can sort of use a decimal, like the probability of something is 0.2. You can use percentages, you can use betting odds, though there's enough complication there that I'm probably going to save how to convert between different betting odds for another video. And the key thing is, even though all of these different ways of representing probability are mathematically equivalent, they all give you the same information, that doesn't mean they're equally intuitive. They're not equally easy to think about, and they're therefore not equally useful when you're actually making a forecast. In order to counteract this, it can be useful to just experiment with different ways of thinking about probability, and I want to give you a couple of ways now. For me, some of these are clearly better than others, but I think the key thing I want to say is just experiment with different ways of thinking, experiment with different ways of framing the same problem, and if one of them starts to feel more natural for you, go with that and experiment with it further. So the thing I do quite a lot, which is probably one of the harder ways to describe, is thinking about different worlds. When I say a probability, when I make a forecast and say something has a 20% chance of happening, I'm making a statement about my degree of belief. Part of that is to do with there being some inherent randomness in the world, but a bigger part of that is just not having perfect information. However, it's not super useful for me, at least, to distinguish between those two things when I'm actually making a forecast. Instead, how I think about it is there's certain possible worlds I could be in where different things are going to happen, and I don't know exactly which one I'm in. To try to make this concrete, maybe I think it's got a 20% chance of raining when I go to work tomorrow. Now, one way I can think about that is, well, at about this time of year, maybe just about once every 5 days I cycle to work, I get rained on. I haven't looked at the weather forecast, so I don't have to incorporate that information. And that's all there is to it. I can imagine sort of 5 possible future versions of myself, and about one of those future versions is wet if they're all currently cycling to work in 24 hours time. For me, coming from a physics background, this has always been quite intuitive, even though I think the discussion of whether the many worlds interpretation of quantum mechanics is actually true or just a nice mathematical trick is far beyond the scope of this course. Just as a way of thinking about stuff, as a way of saying, okay, one way of me saying there's a 10% chance of happening is there's 10 possible future me's and one of them sees this thing happen. That, for me, is quite intuitive. For some people, it probably sounds insane. So let's look at a different way. Another way of thinking about probability is considering in which direction you'd bet and what odds you needed to bet. As I said, I think I'm going to talk about actual betting odds and how to convert them into percentages in a separate video. But one really concrete way you can do this, which I find really useful, is when an event is close to 50% and you want to know A, whether it's exactly 50%, or B, which side of 50% it's on. For me, I think the clearest way I can do this is if someone wanted to bet against me and we were both going to bet the same amount of money, which side of the bet would I want to take? Would I want to bet on the thing happening, or would I want to bet on the thing not happening? I find more often than not, actually, I have a pretty strong intuitive sense of it seems really close to 50, but I definitely want to take this side of the bet. And to me, that means probably more like a 55-60% chance, or equivalently a 45-40% chance, depending on how strongly I'd want to take that side. Some people find this thinking and bets method incredibly intuitive and use it for really different probabilities too. So if something's got a 10% chance of happening, but I think for most people, unless you're already really familiar with gambling, in which case you probably have some decent methods for thinking about probability, the most use of the betting scenario is just thinking, if something's really, really close to evens, can I work out which side it's on? The last way, and this is a way that I think if you deliberately practice it and deliberately think about it, can be incredibly powerful, is just comparing to probabilities of other things you know. There's a die above my head, which is currently saying 3. And I think one way to think about some probabilities is saying, well, what's the chance of rolling a 3 if I only get one shot on a die? It's about 16%, 17%, 1 in 6, if you want to think of it that way. That's definitely the easy way to think about it when it comes to a dice roll. And so, if I think something has a 20% chance of happening, I should think it's a bit more likely than rolling a die and getting a 3. A bit less likely than rolling a die and getting a number less than 3. Now, it's possible to construct a scenario where you can think about any probability in this way. For example, you could imagine you have a bag with some number of counters in it. All of the counters are red apart from some number which are yellow. You can imagine shaking the bag and then going, okay, what's the chance I fill out a yellow counter? I've heard people say this is really useful, and I don't really buy it. For me, constructing that scenario is no more intuitive than just thinking about the maths directly, and it's certainly less intuitive than thinking about another forecast I've already made where I've given a particular probability. However, some people I trust do think that's a useful way to think about things, so I encourage you to experiment with it. If you come to the same conclusion I did, that it's just not very useful, that's fine. But if you don't, it would have been a shame not to have tried it. So now you have at least some ways of thinking about probability you might want to experiment with. I think the key thing is to practice and see which ways are better. Practice is incredibly useful for loads of things, but the difficulty with forecasting is feedback's actually quite difficult to get and quite difficult to interpret when you do have it. As a concrete example, even fairly near-term forecasts often take months to resolve. The problem with that is not only do you have to wait months before you get any feedback about whether or not you were right, but also by the time your first 6-month forecast resolve, you'll have 6 months more experience. I've only been forecasting for about 6 months. I really have no idea how good I am at forecasting 6 months into the future, not least because all of the forecasts I made 6 months ago were me having just started, and I think I'm better then. I've certainly had a lot more practice. So really, if we want to practice some of the skills of forecasting, if we want to train our intuition a bit, we need something with a much faster feedback cycle than forecasting itself that lets us do a bunch of practice but not have to wait several months to get our results. Luckily that tool exists, and I want to kind of talk through how to use it in this next section. So here's what the tool looks like. It's got a whole bunch of different modes, and what I'm going to quickly do now is just show you each of them in turn. So the first thing where I'd recommend you starting is looking at confidence intervals. So you only get a certain amount of time to do the problems. I'm going to try and describe what's going to happen before they actually start. The basic idea here is you're given some question that has an answer that could be a numerical range. Often it's the date, so when does this thing happen? And your goal is to try and give a range that includes the correct date, but to give it small enough that you're wrong at least some of the time. So first you need to choose your confidence interval. Once you've got the idea of this game, I'd actually recommend mixed practice, because even though you get a lower success rate while you're playing, you will end up having higher transfer to other skills. But for now, let's just pick 90%. What that means is I want to answer the questions in such a way that I'm right about 90% of the time. Obviously, one way of guaranteeing this is just to give a very wide range 9 times in a row, and then give an absurdly narrow range the 10th time. That will make me look very calibrated. It also won't be even slightly useful. What I actually strongly recommend here is try to play the game in a way that maximizes the points you get. And after having played the game for a while, then look at the results, which I'll talk about in a minute. The idea with the points is you get more points the smaller your interval is, as long as you're right. If you are wrong, you end up losing points. So let's play 90%, and I'll play probably just a couple of questions. I'm really, really bad at general knowledge, unfortunately. So as much as I can test my calibration from this, I wouldn't emulate any other part of my strategy here. Okay, this question's about Bruce Forsyth's wife. She was voted Miss World in which year? I have 45 seconds to think about this. So I'm going to have to try and talk out loud quickly. So what do I know? I know Bruce Forsyth's pretty old. I think he's the guy that presented Strictly Come Dancing in the UK. So let's guess he's somewhere 80 to 90. I do know that famous men can sometimes have much younger spouses. So I'm going to have a pretty wide range here. I don't have long to calculate this. So I'm just have to grab a number. 80 years ago, terrifyingly, is 1940. So maybe I'll go for 1940 as my lower bound, and she could be much younger than him. So for my upper bound, maybe I'll go for 1990. Okay, 10 seconds left, let's submit. Okay, I'm actually pretty pleased with that. Pleased with it for a couple of reasons. One, if I'm trying to give a confidence interval that's 90% of the time I'm right, I should be pleased every time I'm right. More importantly, the fact that my answer was pretty much in the middle of the range I gave is another thing I'm encouraged by. Could I have given a smaller range? Probably. Honestly, I could probably have given a smaller range if I'd just not had to sort of talk out loud. But there we go. Right, let's try and do one more. Okay, what number does the prefix cent denote? Am I misunderstanding the question here? 0.001? Or 100? Is it 100? So the weird thing is, I'm 90% confident it's just a single number. But if they mean sort of 100th rather than 100, I'm going to be wrong. But you know what, let's go with it. Century is definitely 100. So I'm actually 100% confident, but maybe the 10% is maybe they mean something different. It's okay, let's just go with it. I think I've taught way too much. Bang, okay. You'll notice that I got many more points for that one. That's because my range was much narrower. Frankly, it's because I knew the answer. Then again, you could see I was uncertain here. Part of this, to be honest, is being on camera. But when you talk about a cent, it's it's 0.01 of a dollar. So even though cent definitely is a prefix that means 100, You can see myself second guessing myself there. I don't actually know how confident I would have been in that answer. It probably wouldn't have been higher than 95 because there tends to be about 1 in 20 chance that I just not understanding the question. Okay, that was confidence intervals. Let's go on to the next one. PolitiFact questions. Basic idea here is PolitiFact is a fact-checking organization. So you get given a bunch of statements by American politicians and you're asked to guess how true they are. I reset this calibration game relatively recently so I could show you a slightly more varied calibration curve at the end, which I will do, but I'm terrible at this round, like truly terrible, mostly because I just don't know who the people are who are speaking. But let's have a go because I can at least talk through some logic here. So the basic idea is we're going to give 2 of our truth ratings to a statement that a politician makes, and we have to say how confident we are that one of those 2 ratings will be the answer. Okay, so what rating did PolitiFact give the following statement made by HoustonChronicleTV.com on Wednesday, January 4th, 2017? I've never heard of HoustonChronicle-TV.com. They don't sound like a super reputable news organization, but I'm really not going very much. Okay, the claim. Celine Dion's 16-year-old Renee Charles Angelis was among the 58 victims who were killed in Las Vegas. So weirdly here, I feel like this is either like true or false. Like she was either one of the victims or not. So I'm like actually fairly confident it's either true or false. Like I don't really see how this could be a mostly true or a half true or a mostly false. It could be a pants on fire. So I actually think I have like about a 2/3 chance of getting this right because like it doesn't seem to be any of these, and of the 3 here, yeah, like I have no idea if this happened or not. So I'm gonna go for like 65, which is the closest to 2/3. Let's see how we do. Oh, it was pants on fire, so it was my other one of the 3. Like you'll notice I lost points there, and I'm kind of okay with that because I had no idea whether the thing had happened or not, but I knew that like someone being dead or not is either like true or false. Maybe I should have said, you know what, if it's going to be false, it's probably more pants on fire, but overall I'm okay with that idea. Let's try one more. Okay, John Carl claimed that he did not say that Republicans would filibuster immigration reform. I've no idea who John Carl is. Okay, would Republicans filibuster immigration reform? Probably. Would someone, having claimed that they would, then say, oh, I'm losing track of what's going on here. I'm going to be honest, given that I don't know John Kyle and I don't really know why someone would say and then like restate, I feel like I'm just going to have to guess 2 here and say my chance of being correct is therefore 1 in 3 because I'm picking 2 out of 6 options. I'll pick those 2. I've got no idea. Nah, okay. I was incorrect in guessing. What you'll notice here is, even though I was wrong, I didn't gain or lose any points because I gave essentially an indication that I was guessing. If I'm randomly selecting 2 out of 6 options, then I shouldn't lose any points for guessing. I also shouldn't gain any. I think that's probably enough of that. Let's go to the next one. So, correlations. I don't think I've actually played this since I reset. This is really fun. Essentially what you do is you just look at a scatter graph and you have to guess the correlation. So this is quite good. Okay. We have to say whether it's true or false, and then we have to say what chance correct. Is this correlation smaller than 0.54? Doesn't look like it. So I'm going to go with no, it's not. And I'm like relatively confident. I'm going to go like 75% confident. Nice. Okay, it was miles off. Thinking about it, like given I had to say it was not smaller than 0.54, there's a chance I should have actually been more confident there. So we can get some feedback from that. Okay, let's try one more. Oh god. It looks just about positive. Bigger than 0.49. Oh wait, no, just about positive. And correlation would be 0. Yeah, I think this is not true. And I'm like slightly more confident than I was in the last one. So let's see. Oh, god, okay, 0.6. I did terribly. Probably because I kind of slightly misunderstood correlation there. Maybe I'll cut this, but I'll be honest and not. Okay. Right, smaller than 0.79. Yeah, it's fairly like scattered. It looks a little like a quadratic with loads of noise, like negative quadratic with loads of noise added actually. Maybe I'm anchoring too much on that point. I'm like pretty unsure about this. So, oh, I don't have long left. Yeah, I think it is smaller, but I'm not very sure. Nice, okay. Let's try one more. Okay, smaller than 0.31. Well, I can barely see any correlation here at all. So I think it is smaller than 0.31. But I'm kind of burned by the one I got wrong. So no, I'm still pretty confident. Let's go with 17. Bang, okay. Right, that was correlations. Let's try city populations. Possibly my worst, though I've said I'm bad at all of them. Okay, basic idea. You have to say whether a statement's true or false. It's comparing the size of two cities. Okay, so India's massive and South Korea is like less massive. So I'm going to guess this is true, but I've never heard of... No, I think I have heard of Jaipur. And I haven't heard of Busan, so that makes it slightly more likely that Jaipur is bigger. So I'm going to guess 60% because I really don't know much about cities. Great. Okay, Shanghai had a larger metro population than Recife. I know Brazil's like really populous, but so is China, and I think Shanghai is like particularly populous even within China. So I'm more confident, but I've just realized I got one wrong, and I'm now second guessing myself. Okay, wow, okay, there's a factor of 10 difference. Fine, let's do one more. All right, Shenyang, Philadelphia. I haven't heard of Shenyang. I have heard of Philadelphia, but obviously China's really big. This is just a guess, so 50%, like I've got no idea. I'm not too upset about guessing. They were only like, one's only like 10% bigger than the other. Okay, let's do one more. I've got no idea. Like, this is not very useful. I'm just going to show you a 50% guess again. I'll get to one where I can actually make a guess. Okay, Milan and Tianjin. So this is difficult because I've no idea how big Tianjin is, but I do know Milan is one of the biggest cities in Italy. Having said that, I'm going to go with China just having really populous cities. So I'm going to guess false, but I'm not very confident. But like, I think I'd do slightly better than guessing on average here, so let's go 55. Okay, I was right. It was about a factor of 2. Let's try one more. Addis Ababa and Kano. So I've actually heard of like a few cities in Nigeria, and I haven't heard of Kano. But I have definitely heard of Addis Ababa, so I'm going to go true. But I'm like pretty uncertain here, especially as Nigeria is like massive in terms of populations. I don't know. I don't actually know if I'm even better than guessing. But I've only got 10 seconds left, so. Well, okay, they were really close. So like, I'm not super upset there. Okay, that's city populations. Let's try one more. Maths problems. I'm a maths teacher. That's my day job. So this has the potential to be super embarrassing, but let's go with it. Okay, yeah, you basically got to solve a bunch of maths in your head. I'm probably gonna have to do this without talking. Sorry, you can just see me wince. Oh god, it's like 19/22. Oh, I don't think that is smaller, but I don't have time to work it out. Oh god. Okay. Did I just mess up the maths? That is 19. Oh, 19/23. No, it's 19/29. I just can't do maths. That's obviously smaller. Great maths teacher. Don't fire me, please. Okay. 6 times 81's like, oh, that's got to be bigger than 340. Nice, yeah, okay. 145 divided by 24. It's like 6. That's not bigger than 9. But I'm not very confident in this. I should have been way more confident, actually. I think I was just like, I'm on camera and I'm doing maths in my head live. Yeah, okay. Wasn't confident enough. Okay. Right, so that's 13 on 27. That's definitely bigger than 0.24. Have I messed up the maths? I've got 20 seconds. 13 on 27. Yeah, like. Oh, we're gonna get the right way around. 13 on 27 is definitely bigger. You have no idea how stressful that was. I really can't express how difficult it is doing very simple maths when you know you're gonna have to publish the results. Nice. Okay, that's enough of that. And free answer trivia. Okay, so what's going on here? I think basically you just get asked a thing and you have to type an answer and then you have to say how confident you are in the answer. But like, it's a bit weird because if there's two plausible answers, you have to guess like which one the kind of question writer is thinking of. So there's always some uncertainty. I think you get given like a certain number of letters though. Anyway, let's see. Who won the Champions League in 1985? Well, my best guess is going to be Barcelona, because they won it a whole bunch. And like, okay, what teams could plausibly have won it? It's probably about like, it's probably less than 20, or like, I think Barcelona has definitely won more than 1/20th of the Champions Leagues, but probably less than a 10th. So I think 10% is going to be the best guess here. Okay, fine. Madagascar is off which coast of Africa? Well, it's definitely the east coast, and I'm like pretty sure they mean east, but like maybe there's another word for it. So I'm gonna go with like 95%. Nice, okay. Who had a 1994 #1 with I Swear? I don't know. It's one word. Who's a one-word artist? Madonna's a one-word artist. And like, there's loads of people who've made singles, so I think it's a decent guess, but 5%, 3%. Go with 3. Cool. I'm like fine for that. Never heard of All for One. All right, let's do one more. Asian elephants, and then national habitat. I think it's India. Like, it's probably like 4, 5 countries it could plausibly be, plus some chance that I've misunderstood the question, someone camera, so I think 20% is about right. Oh, probably should have been more confident. Right, let's do one more. In Dumbo, the mouse who prevents Dumbo. I've got no idea. 1%'s too low. Fred, let's go with Fred. Is Fred the mouse? Fred is not the mouse. It turned out to be Timothy. Okay, so let's have a look at results, and then I want to talk a bit more about like how to actually use this now you've kind of seen me play it. So the first thing to do is let's scroll down to my calibration for all questions. So how to interpret this graph. Let's just check and see the whole thing. Right, what we have on the left-hand side is how often I was right when I gave a particular probability. What we have on the bottom is different probabilities I gave. The first thing to point out here, and this is why I actually reset my score to play again, was the grey circles basically don't pay any attention to. Like, the sample size is just too small. The black circles, however, have at least 20 responses in them. So my let's look at this particular point. So for 30 questions I answered, I've got a 50% chance of getting it right. And actually it looks like I got exactly 15 of them right. I'm pretty pleased with that. I think I'm well calibrated at 50%. Certainly that's actually better than my Metaculus calibration at 50%. When we go up to, I'm not really sure what's going on here. I think the aspect ratio is slightly wrong, but this is probably like 65, no, maybe 60%. So 83 responses at 60. And it looks like I got them right a bit more than 60% of the time. This is still definitely like within the margin of error, but it looks like I might be very slightly underconfident at 60%, i.e. when I say something has a 60% chance of happening, it happens like a little bit more than that. When we get to 70%, 25 responses here, so not huge, it looks like I'm fairly well calibrated. So like if I say something has a 70% chance of happening, it happens about 70% of the time. If we look up at the top, we can see that things I said were 95% likely to happen have happened 100% of the time. This isn't an indication of underconfidence on my part, because there's only been 4 of those things. I think this is time to really, really emphasize that there's a way of doing this calibration training which is a really bad idea. Just, you won't get any value from it, even though it's still quite fun. And that way would be doing a few questions, looking at this plot, and then saying, okay, well, I've got to get some questions at 20% wrong, and I've got to get some questions at 75% wrong, and then I've got to get some questions at 45% right. Okay, that's a terrible way of thinking. What that's doing is trying to make this calibration curve look like you're well calibrated. Having a calibration curve that looks like you're well calibrated is not useful to anyone. What's useful is being well calibrated. So what I really, really strongly recommend if you want to get really good at forecasting is try one or two of those exercises, the ones that I just live played. Whichever one looks most fun to you, start with that one. But complete all the questions before you look at this graph, i.e. doing exactly what I didn't do. Don't click on results, answer all the questions. Then what you'll have is actually really valuable information about where you're overconfident and where you're underconfident. That's quite different to trying to make the graph look nice. Ideally, what you can then do is kind of experiment with different ways of thinking about probability. Even just be aware that, let's say you found, and actually, let's use an example from me. When I first did this training, and I did all of the training, I found that my sort of 99% sort of calibration, if I said something was 99% likely to happen, it happened about 95% of the time. That's actually turned into a really useful rule of thumb for me, because I was thinking about those questions for about a minute. And so essentially what that says is, if I've thought about something for about a minute and I'm completely sure it's going to happen, it'll happen about 95% of the time, i.e. about 1 in 20 times I completely misread a question if I've only spent a minute on it and I haven't thought that hard. That's useful for me. It means when I look at a question that I want to make a forecast on and I think about it for a minute and I go, there's just no way, like there's absolutely no way that can happen, I can just put 5%. If I then go and do more research, I might pull it lower, but it gives me like a really useful rule of thumb to say, actually, that for me is like the chance I've just grossly misunderstood something. So if you want to get really good at judging probability, if you want to get really well calibrated, don't try and make this graph look good. Just do all the questions, have some fun with it, and then when you're finished, when you've answered all the questions, look at your graph and see whether or not you are appropriately calibrated at different percentages. The massively large sample you'll build up is going to be really invaluable. Just as a counterpoint while we end, I want to show you that you can do the same thing on Metaculus, and I actually have my Metaculus calibration curve loaded up. What you can see here is it looks a lot worse. Now, I'm going to make a claim that at least some of that actually is just a much lower sample size. I have only actually made sort of 116 predictions. Well, I've made like 1,200, but only 116 questions on Metaculus have resolved for me. What that means is, if there's like 20 different bars here, I think this is 20, I'm just taking a guess. If there's 20 different bars here, each one of those on average only has like 5-ish guesses in it. And so it shouldn't be super surprising that I don't look brilliantly calibrated. I think I got quite lucky in that nothing I've predicted more than 75% chance of has happened. And I think it's also worth saying that, like, if I see myself being underconfident at 75% and underconfident at 80%, but like overconfident at 77%, I can reasonably kind of go, well, maybe those are going to average out in the long term and I'm relatively well calibrated. I am a little concerned by the, like, every time I've guessed sort of between 30 and 50% chance of something, it's never happened, at least on Metaculus. But that's when I can say, okay, well, I've got a pretty big sample in the 50% range in the Open Philanthropy calibration game, and I seem to be well calibrated there. Having said that, there's only 3 responses at 45, and there's 8 responses at 40. So this is not yet an area of concern for me, but it's something I might, go and finish the 50% game for a second time in Open Phil, and that might be useful for me to sort of check. Again, with this, I do not recommend in the slightest you saying, I need to fix my calibration curve. So, like, I could say, next time I think something's certain to happen, I'll predict 77% on it to move this bar up. And I could say, next time something's like 90% to happen, I'll predict, next time something's really unlikely to happen, I'll predict 90% on it to bring this bar down. Like, that makes me look better, but doesn't actually make me a better forecaster. Okay, I'm going to put a link to the calibration game in the comments down below. Let me know how you get on. It'd be really cool to see people posting their calibration curves either as comments or like on my Twitter or something. I think I might sort of do a live stream where I kind of finish off the calibration game. That'll be something for once the entire intro series is finished. But until then, it'd be really nice to get some feedback, especially on whether this sort of calibration process has made you feel any better as a forecaster. See you next time.